Okay. Good morning, everyone. Let us come back to the classes of structure analysis 2. So, I hope all of you have given the examinations. If you have not given the examinations, it's your problem. I can't say anything. Now, the main thing is that we are in the verge of ending the syllabus, or we are in the verge of completing the syllabus of structure analysis 2. I hope everyone is practicing rigorously this subject because this subject, as you know, it contains highest credit of 4 points. And regarding the examinations, if the exams will be online or offline, that also we don't know. Okay, so we don't. All of us we don't know what will happen in the future. So keeping in mind, first of all, those who have missed the examinations, I want to tell you, it was a very good opportunity to practice and to have a examination atmosphere which was absent in your life for the last 1.5 years. I know no one wants examination, but still it is a learning process. Always remember, examination is a learning process to evaluate yourself, because during the campus placements, those who are going for core company job, if you are not sitting for this examination, it will be completely zero for you. Okay, so at least sit for the examinations and feel the exam environment. And for end-sem examination, if the examinations are occurring offline, that means you have to come to college and give examination, then it will be a complete nightmare to you all, because the huge lengthy syllabus where you will really find very difficult and hard to cope up and to complete the examination within 3 hours. Okay. So I should say you should practice very in a smart manner. Please work hard, work as well as work smart. Okay, just work smart and at least have a knowledge whatever is being taught in a subjects. Okay, and practice. Okay, because in the future no one knows in which mode the exam will take place. Please keep this in mind. I'm telling because of there is some reason. Okay. So, coming back to the last class, where in the last class we have learned that how to develop the flexibility matrices, and how to use the flexibility matrices in our problems. Am I audible? I'm just asking.
Yes, sir.
Okay.
Yes, sir.
Okay. Thank you, everyone. So, first important thing is that so today, as you know, that we in the last day we solved a numerical problem on flexibility method, and we use flexibility matrices. So today, the last day, I showed you how we can do that problem, how we can solve or how we can analyze a continuous beam using the method one. That is, we had taken the vertical reactions at the coordinates, and we have assigned the coordinates at respective unknown redundants, and we have found out the reactions. Okay, the unknowns were the redundants were reaction. While today we will learn, and the last day I did not get any good amount of time. So let me share today. I will discuss with you the method two. Okay, the second method to solve any beam, any continuous beam using flexibility method, where the redundants are moments. Okay, where the redundants are moments, and it is much easier. It is smaller technique and easier technique compared to the previous one. The previous one is very important. If question comes like find out the reaction, unknown reaction, then method one will be very much effective. As you know, I have taught you last day. So today we will come to the method two, and this method two is given in SS Bhavikatti book. Okay, please make sure the method two is given in SS Bhavikatti book. The procedure which they have used, then the procedure which I will use in my class is different. Okay, and my procedure is slightly easier compared to the book version. Okay, after completing the flexibility, we will start with the stiffness matrix method. Also, we will solve the same type of numerical using stiffness method. Okay, so learning the flexibility method and stiffness method, our syllabus will come to an end. Okay. And you will, as I know, I told you that you will get 12 marks question or something like 6 plus 4 marks or 8 plus 4 or 6 plus 4 in this fashion from this module 4. Okay, that is in this chapter. Now coming to today, we were continuing with the flexibility method. What is the other name of flexibility method? Other name of flexibility matrix method is force method. You all know. So here, force method. Okay, force method. And please make sure whatever the classes I'm taking or PBC madam is taking, please make sure to attend the class even if you're not willing or even if you're not wanting to do the class. Please listen to the lectures, okay? And please tell the faculty members to record the class so that you can you can go through those classes again and again, okay? Again and again you can go through those classes so that it will be helpful for you, because doing this subject in online is an extremely tedious and tough job. Okay, I'm trying my level best to teach you. You have to try your level best to learn. Okay, very important. So flexibility method we are doing. So today we will do using method 2. So let me draw the diagram again. The diagram which we used, the continuous beam. So the same question. We are using the same question, and as I told you, as I promised you that today we will solve using method 2. Solve using method 2. Method 2 is obviously very much utility, is main utility is very much important to, very much useful to find out bending moment diagram. Useful to find out bending moment diagram. BMD. Okay. As I told you, this matrix method is very important as far as BTech is concerned, because all the softwares like StatPro, ETAP, all the finite element based softwares, they use this matrix method. And if we don't have this matrix method knowledge, then if we solve any structure, if we design any structure in any software, we will not able to understand. Okay, this is why matrix method is very much important. I am not making this subject very difficult, because here we also had inclined members, we had cross members. I am not teaching all those things. Okay, just making simple. In fourth year, those who want to opt the elective paper, that is advanced structure analysis, there you will get a huge amount of chapters which are based on matrix method. Okay, so your basic knowledge will be required. So coming to very much useful to find out bending moment diagram. Okay, so this is the numerical which I discussed last day. So we had a prop cantilever beam, the same beam. Even in examination also you will get this type of beam only, maybe 2 span or 3 span, and you have to solve the number. The ABC, okay, and AB we had AB. The length of AB was 4 meter, and the length of BC was 3 meter. And on AB we had UDL. I hope everyone is maintaining a notes copy, because if you're not able to maintain a note copy, it will be very difficult for you to learn this subject. So 60 kN per meter UDL, and we had point load on BC, which is located at the midpoint. Okay. So as I told you in the last class, in the last method, we took this one. In the last method, we took A coordinate 1 and B coordinate 2. Okay. But now in method 2, if you take method 2 means here we are using method 2. So if you like, please make sure method 2. Method 2 is very much easier compared to method 1. I'm telling you. Okay? Method 2, it is given in Bhavikati. So method 2, The same way here we are using so taking or assuming moments as redundant. Moments as redundant. Okay. So where we will take the redundant? So we will take, as I told you, we were taking moment as redundant. We will take the moments at uh, here at M, that is at A and B, because we know the moment at C is 0 because it is single supported end at the end part. The moment at C is 0, you all know while learning slope deflection and moment distribution method. Okay. So coming to A and B, so I am taking A as coordinate 1, B as coordinate 2. Okay. Coordinate 2. So here these are two redundants. As I told you in the last day also, our degree of static independence was 2, as we have found out. Okay. So here now, since moments are taken as redundant, so here we can surely say, someone can tell me, sir, why we are not taking B and C, just like in method 1? In method 1, B and C were redundant and forces. But when we are coming to method 2, if we tell that moment C is unknown, it is not unknown because it is at the end and it is single support. Yes. Now, if the C was fixed end, if the C would have been fixed end, then it would have been unknown moment. Then it would have been redundant, right? So here C is at the end, simply supported. That means at the end, if there is a roller support or hinge support, please make sure. These are fundamental structure analysis which knowledge you should have to know. Okay, all these questions are asked in an interview. So at the C end, if this is the end support, if this end support is roller support or hinge support, then your moment is directly zero. This is very useful in slope deflection as well as moment distribution method also. Okay, so C is 0. So this is not unknown. So the only two supports are unknown. So we can take two supports. Obviously, we know that B is intermediate support. Obviously, B is the intermediate support. It has unknown moments. While at end A, it is fixed end. Here we have fixed end. Fixed end we have three unknowns. Reactions in horizontal axis fx 0, fy 0, sorry, fx, fy and moment. So three unknowns are there. So we have unknown moment at A also, end A. Okay. I'm requesting my students not to please join and leave the meeting. If you're really interested to learn, then you can join. Please don't meet, because at the end of the class, I will again take the same type of interview like what you have learned during taking the attendance. Okay. So degree of studying means do. Now come, so what is the step? So here in this method, I am assuming moment is unknown. So please write in your copy. We are assuming moments at A and B as redundant. Okay, redundant. Okay. So obviously, so A is coordinate 1, B is coordinate 2. Okay. So now after this, what is the important thing? The important thing is after this, follow the chart which I had given you. Follow the chart. The results follow the chart of slope deflection which I mailed you. Okay, everyone should have a printout of that sheet. Okay, so if you see the chart of slope deflection, you will see that. So now, what will I do? Why will I use this? Because now I am going to find out the flexibility matrix. So step one is this one. Step 2, if I see, find out flexibility matrix. Find out flexibility matrix. Find out flexibility matrix. Okay. Flexibility matrix. So how will I find out first? I know that it is 2 ds2. That means the matrix will be 2 by 2. 2 by 2. Then it will be something like this: f11, f21, f12, f22. And all of it we know that we move column wise. Okay. F11, F21, F12, F22. We move column wise. We find out the flexibility coefficient column wise. Okay. So now first, so in matrix one, first write down. So it will be 2 by 2 matrix. Similar, just like method one. So first we will go for case one. Case one. What is case one? Case one is we will put unit force or unit moment. We will put unit moment at A as 1. That means, as I told you, very important that we will remove this indeterminacy into determinate structure. As I told you, we will convert this indeterminate structure into determinate structure, right? So what will I do? I will take it. I will make it single supported beam. Okay, single supported beam A, B, as well as C. So I am converting the whole indeterminate structure into determinate structure. So here coordinate 1 at a moment at A, because moment is, as I told you, moment is and also generalized force, this type of force. Similarly at B we have, so at B also we have moment. B is coordinate 2. Okay. So now, so this is the primary structure, as I told you. It is the primary or release structure. Primary or released structure. What is this? That means I am removing the external loads and I am just converting this indeterminate structure to determinate. Okay. Now I will break this beam in two different parts. So A, B. So here, and obviously A, B. And similarly, we have, it is B and C. A, B, B and C. Correct? A, B and B and C. So I've converted all the fixed end into single supported ends. Next, I'm dividing into two individual single supported beam. That is, this is a determinate beam, determinate structure. Here, determinate structure. So now, in this case, coming to case one, what I written? Put unit moment at 1 is 0. That means I will put a moment at A is equals to 1. Okay. So I will take moment A at 1. Okay. So now what will I have? So when I am putting unit moment A at 1, so obviously due to moment I will have slope. I will have slope. So this is what? Theta A. Slope or the rotation at end A. Theta A. Okay. Correct. So slope at end A. Theta A. So due to this, so I am putting unit force. A force means moment is also a force. So I am putting unit moment. That is, unit moment is occurring at this point. Okay. So now theta is, so here with respect to this I will get F11 and at B I will get F21. Okay. So for this part, for case 1, putting unit moment at end A, that is moment at end A is 1 kilonewton meter. Moment at end A 1 kilonewton meter. Okay. So now based on this I will give two coefficients, F11, F21. F1 means rotation or unit force at 1. Due to that, what is the displacement? So displacement at 1 due to unit force as 1, and F21 means displacement at 2 due to unit force at 1. Here I am putting unit force. So therefore, now we will follow the chart and we will find out what is F11. F11 will be what? Simple theta A. Simple theta A. Slope at end A. Okay. Slope at end A. These values you will get from that chart which I mailed you. Have you got all of you this chart? Yes or no?
Yes, sir.
Yes, sir.
I had mailed you, right? So that chart is very much important. We chart na mone rakhle. If you're not able to remember the chart, it will be slightly difficult for you to do this. Okay. So F11, that is slope at 1. If you see, that means if you see the chart, these are near end, these are far end. So near end means the end of the joint end where I'm providing the moment. So this is the near end, this is the far end. A is the near end, B is the far end. So you will see that when we will have a single supported end, the near end, the formula, the flexibility, see here, flexibility of the slope is nothing but L by 3EI. L by 3EI. If you see the chart and you find out. So the near end, why? End is the near end. So the near end, the flexibility of the slope is L by 3EI. So here, let us, that's what is the length? L is 4 meter. So 4 by 3EI. So 4 by 3EI. Okay. So near end. Now coming to far end, B. So F21. So the flexibility is F21. That is displacement at 2 due to unit moment at 1. So here it will slope theta B. So you will see the far end of the slope at the far end, that is theta B. So why, which is near and far end? I am providing moment at end A. So A may, since I am providing moment at end A, that is end A is the near end and B is the far end. In reverse, if I provide moment at B, then B will be the near end and A will be the far end. Okay, which will come in case 2. First, let us focus on case 1. So case 1, B is the far end. So for far end, you will see the formula is L by 6 here. L by 6 here. Okay. The chart which I have given you is a very, very famous chart, an important chart. You will not get that chart from very good books also. It is taken from medicine study material. It's a very good chart which is very important for your MCQ, matrix method solving, everything. Okay. The L by 6 EI, so here it will be 4 by 6 EI. 4 by 6 EI. Okay. F21, if you can make it 2 by 3 EI also. So it is in fact 2 by 3 EI. Have you understood case 1? I am putting unit moment. The moment is also a force. So putting unit moment here. I have got theta B and theta A and theta A is F11, theta B is F2. Understood? This is case 1. Any problem?
স্যার
হ্যাঁ বলো।
স্যার যখন ইউনিট মোমেন্টটা এতে এতে পুট করা হচ্ছে তখন যেটা ওই F21 এর যেটা লিখেছেন না ফর্মুলাটা, তো সেটা
হ্যাঁ
ফার এন্ড হিসেবে ট্রিট করছেন তাই তো?
রাইট। কেন ফার এন্ড কেন হচ্ছে 2 টা হচ্ছে B তে আছে,
হ্যাঁ হ্যাঁ
রাইট? B 2 তে B তে, তো F21 মানে কি 2 তে হচ্ছে ডিসপ্লেসমেন্ট এট B ডিউ টু ইউনিট ফোর্স অর ইউনিট মোমেন্ট এট 1। তো 1 এর জন্য B তে কত এফেক্ট হচ্ছে, এটা
স্যার
F21।
মোমেন্টটা যদি বি তে কনসিডার করা হতো তাহলে সেক্ষেত্রে পয়েন্ট
হ্যাঁ
এটাকে ফার এন্ড হিসেবে ট্রিট হতো তখন।
রাইট, কারেক্ট। আমি যেটা কেস 2 তে করব এবার, ঠিক আছে?
ঠিক আছে
এটা
ঠিক
আমি
আছে।
কেস 2 তে করব। গুড কোশ্চেন। So case 2 put, so in case 2, so we will again draw the diagram in A. So now in case 2 I will put unit moment at B. Put unit moment at B 1 kN. That means I will put the bending moment or the unit moment at B as 1 kilonewton meter. Okay. Now very interesting to see that this support B, it is lying in both the support, both the beams. So we have to consider both the beams. Okay. So AB as well as BC. So here AB as well as BC. So it is coordinate 2. So here I will take MB as 1. So B is a common support. So here for AB also I will take MB. For BC also I will take MB 1. Correct? So due to this, what will be my value? So due to this also I will get the slope. One is theta B, for B may be theta A. So similarly for B here, for B since it is common support, so these two we will take as F22. That is displacement at 2 due to unit moment at 2, at coordinate 2 I am providing unit moment, and here also F12 theta B. So very importantly, find this diagram. These diagrams will help you to solve the problem 80%. Okay. So this beam, this diagram will help you to solve 80% problem. If you do not do the diagrams, I'm telling you, practically in matrix method, it will be very difficult for you to find out the flexibility or matrix elements. Okay. So if I come to, I'm putting moment at B1. So B is, so we have this contribution. So we have contribution theta B for AB as well as theta B for BC. That total we will take at F22. Understood? So F22 is here. F22 means, you will tell me what will the value. F22 means the flexibility or displacement at 2 due to unit moment at 2. So here I will take theta B for AB part as well as theta B for BC. I am not showing slope at C because C is not a coordinate, so I am not interested. Understood? কিভাবে কি করছি? So I am not showing. You can show the slope at C, but C we are not interested. Okay? So for to find out theta B, so theta BAB plus theta BBC. Why I am taking? Because B is lying on AB as well as BC. So what will be theta BAB? You tell me.
L/3.
Very good, because B is the near end. So L by 3I, that means the length is 4. So 4 by 3I plus again coming to the for BC also. For BC also B is the near end. So L by 3I, that is length for BC is 6 meter. Sorry, it is 3 meter. BC is 3 meter. So 3 by 3I, it will be 7 by 3I. So F22 is the slope at B due to AB as well as B. Please someone tell Saurabh Kumar not to join. Roll number 32, tell him not to join. Okay. So F22. Similarly, F12, what will be F12? You will tell me the answer. F12 here.
L by 3I.
F12 means theta A. Theta A means the far end. Okay. Theta is the far end. 4 by L by 6CI. A is the far end, right? As I told you, in case 1, A was the near end, B was the far end. So when B was the far end, what was the formula? L by 6CI. Now here in this case 2, A is the far end. The formula will be L by 6CI. It is L is the 4 meter. So 4 by 6CI. Simple. Okay. So this is how we can see we have got all the coordinates F11, F21, F22, F1. Okay. Okay. So we have got these all the flexibility elements. See here, column wise F11, F21, F22, F12. Okay. Okay. Saurav Kumar, you have joined, but I will not take your attention. Okay. So now we will plot this in the matrix. Step 3. So please take this down slowly, then I will rub the erase the book. First to copy this down. So take this down, then I will you copy this down, then I will erase this. All of you please copy this down, then I will erase this. You tell me when you have copied. So can I erase this part? This case 2?
Yes, sir.
Okay. So now we will come to the step 3. We will come to step 3, that is develop the flexibility matrix and F inverse. We need this inverse of matrix and all these things. So let us, so F matrix, it is for 4 element F11, F21, F12, F22. So we have 2 by 2 matrix, because as we know the degree of static indeterminacy was 2, number of redundants 2, so 2 by 2 matrix. So here if I take 1 by ei common outside, if 11 was 4 by 3, if 21 4 by 6, if 22 4 by 6, and 7 by 3. So this is the flexibility matrix for this numerical problem. This is the flexibility matrix. Okay. So now I will find out the inverse. You all find out slowly. So to find out the inverse is very important. So the inverse of the matrix will be nothing but adjoint of flexibility matrix divided by the determinant of the matrix. So we know adjoint of flexibility matrix is nothing but just change the diagonal elements. Change the interchange the positions of main diagonal elements and change the sign of minor diagonal elements. Okay. And the determinate value you can find out. So this is how you will so this is how you can find out the inverse. So just for adjoint of matrix, interchange the elements of main diagonal element, and for minor diagonal, just change the sign. Okay. And determinate value, you know, 4 by 3 into 7 by 3 this minus this. Okay. So here after doing all these things, the matrix which we have got, let me write it down. So the F inverse matrix will be nothing but EI 0.877. I am changing it in decimal point. EI 0.877 by 0 minus 0.251 minus 0.251 0.50. This is how you will get the inverse of the matrix. So now we have got the inverse of the matrix. This is step 3. Now coming to step 4. So now step 4, till now we had used the primary or release structure. That means I have not allowed any external load coming on the beam, which was given in the question. Now in step 4, I will find out the deflection due to external loading. That is, for AB, I will find out, I will put the UDL, and for BC, I will put the point load. So step 4. So find out displacements. Find out displacements due to external loading. Find out displacements due to external loading. Find out displacement due to external loading. Okay. So now what will I do? I will put the external loads. So for AB, obviously the single supported ends will continue. AB, BC. Okay, so AB, BC. So for AB, I will take UDL. So now I am putting the external loads. As I told you, I put UDL, and for BC, I will put the point load. So whatever the external loads was there, I will put these things. Correct. So A is coordinate 1, B is coordinate 2. So now I will find out the displacement due to external loading. Okay. So displacement means what? So due to this external loading, the slopes, nothing but the slope. So for end A, we have slope theta A, theta B. Similarly for BC, we have theta B, all these things. Okay. So therefore, first delta 1L. Delta, so what I have did on the primary structure, I have kept it single supported beam. That is, I have kept the determinate structure, and I have put the external loading. So due to this, what would be my deflection that I will check out? This part is similar to method 1. This procedure, step 4, is similar to method 1. So for delta 1L, that is displacement due to external loading in coordinate 1. In coordinate 1, that is A. So A, it will be, so A will be theta A. So it will be what? WL power 4, WL cube by 24 EI. WL cube by 24 EI. Okay. So 60 into 4 cube by 24 EI. WL cube by 24 EI. So it is coming 160 by EI. So theta A, that is the slope at end A. Theta A, slope at end A, that is nothing but the deflection or the displacement or deflection at coordinate 1 due to the external load UDL. Similarly, coming to delta 2, that is for 2. So delta 2 is deflection at coordinate 2 due to external load. If you see coordinate 2B is located in both the supports, so we will take the contribution from both the supports. That is theta B from beam AB plus theta B from beam AB as well as theta B from BC. Theta B from BC. Okay. So here, as you know, coordinate 2 is the common point, B is a common joint. So AB as well as for BC. So for B point, it will be simple WL cube by 24 EI plus for BC, which is carrying a point load at midspan, it will be WL square by 3 EI. WL square by 16 EI, sorry. So 60 plus point load 100 . So first, the deflection at support B due to AB and at deflection at B due to BC. The total I am taking as 216.25 by EI. So finally, the last compatible equation which I will put, that is matrix R equals to F inverse into minus of delta L. So therefore, so this is the last equation. That is step 5. Step 5 will be the last step where we will put the compatibility equation to solve the unknowns. Unknown means MA and MB. So this is the compatible equation we had also used in method 1 also. Okay. So R equals to F inverse into minus delta L. So R1 is the R1, R2, it is unknown. R1, R2 is basically, here it is moments, so MA, MB. R1, R2 is nothing but in the form of MA, MB. That is equals to, you put the F inverse, so I am putting the matrix, that is the inverse flexibility matrix. And 0.51 is equal to 0. So this into so putting these values, find out moment A and moment B. Your task is to find out moment A and moment B. I hope you can see the board. Slowly you find out and tell me the answer. So it is EI 0.877. This is the inverse flexibility matrix multiplied with, put this delta 1L, delta 2L. You can see it is delta 1L is 1 by EI taken common. First is minus 160 and below it is minus 216.25. Slowly calculate and tell me the answer.
Sir,
Any
Sir,
doubt
which
in
is
this problem, you can ask me. No problem.
হ্যাঁ স্যার বলছি স্টেপ 5টা একবার বলে দেবেন, ঠিক ওটা ক্লিয়ার হলো না।
Step 5 টা হচ্ছে compatibility equation put করলাম। এই method 1 এ কি করেছিলাম? Now that is the R matrix is equals to F inverse matrix into minus delta L. এটা হচ্ছে compatible equation which I have to remember to solve the unknowns. Unknowns গুলোকে বার করছি এবার। MA MB তো unknown. Moment at A and moment at B হচ্ছে redundant unknowns. So now I am finding out the unknowns here. যেরকম মেথড 1 এও করেছিলাম, unknowns বার করে রিঅ্যাকশন বার করেছিলাম। RB and RC, just take your copy. এটা হচ্ছে কম্প্যাটিবল ইকুয়েশন, এটাকে মনে রাখতে হবে। যেরকম ম্যাট্রিক্স মেথডে আছে, যেরকম ফ্লেক্সিবিলিটি মেথডে আছে, স্টিফনেস মেথডে ওরকম আছে। আমাকে সলভ করে আননোনটা বার করছি। দিস কল কম্প্যাটিবল ইকুয়েশন, অ্যাজ আই টোল্ড ইউ। So from here, from this matrix multiplication, find out MA MB.
Sir,
বলো।
MA equals to minus 86.042
MA
আর
is
MB
coming minus 82.042. Very good.
আর MB equals to 868 minus 68.18.
Very good. তাহলে MA MB বার করার পর, after you get MA MB, draw the bending moment diagram. Okay. One, due to this, that is the joint end moments, and due to that is the simple supported beam জন্য I'm drawing this down. So very good, good answer. So MA is coming, very good. So MA is coming minus 86.04. Please everyone write this down. MA is coming minus 86.04 and MB is coming minus 68.18. 68.18 kilonewton meter. So after this, so everyone please take this down. Then in the last step, in step 6, this is step 5. In step 6, we will plot the bending moment diagram. Just like the bending moment diagram which we used to do in slope deflection or moment distribution method. Same way, draw the bending moment diagram due to end moments. These are end moments, and overlap that bending moment diagram with free bending moment diagram. That you know how to draw the bending moment diagram for in intermediate continuous beams. You know, these
Yes,
are
sir.
all intermediate. জানো তো অর্ঘ্য?
Yes, sir.
Okay. So please take this down, all of you. Then I will erase this part. And lastly, we will draw the bending moment diagram. Please, I am telling you, everyone, those who are not giving importance to this subject, or those who are not listening to these classes, it will be very dangerous for you only in your future career. I'm telling you. First of all, we have a lot of problems. We are in a disadvantaged position that we are all an online batch. I'm telling you. We are all civil engineering students. The companies will come and tell you that you are online batch, so you don't know anything. So you have to learn on your own. And obviously, we are always there. But these fundamental concepts which I am teaching, or any professor is teaching, please try to take this down in your notebook. It happens in many companies instantly. In code companies, I have when I have sent my students, the first question was, please draw a bending moment diagram for this beam. The first basic question in a code company, a design company like this. And if you fail to do it properly, in that instant you are cancelled. So taking down this part, everyone, at least everyone, please practice the structure analysis 1 and 2, estimation and costing, concrete technology, that mid-line part. Please learn this very important. RCC, obviously. RCC, estimation and costing, structure 1 and 2, are the most important subjects. As well as you have steel design in the next semester, then also you will understand how important it is. Okay, so now we are going to solve this. So step 6. Step 6 will be just sketch the bending moment diagram. Those who have given intern examination, surely I can tell you they will get 30 upon 30. Straight 30 upon 30 and intern examination. Okay? Already I told you in the class also. Okay, so the last diagram, last part. So obviously we had found out MA. So let me write down the value. So MA we had got minus 86.04. MB as minus 68.1. Okay. Now, obviously, we have to calculate the free Benjamin diagram also. Free BMD. Free BMD means what? The bending moment due to external loads. Bending moment due to external loads on simply supported beam. On simply supported beam. So now, along with these moments, let me draw the diagram. A, B, and C. So A it is 86.04. From here, let's see the diagram. So 86.04 and this is 68.18. Okay, AB and AB. Okay, now this thing and free bending moment diagram for AB, maximum bending moment diagram for B maybe. AB was UDL, maximum bending moment diagram for AB. It was UDL, so WL square by 8. How much you tell me the answer? WL square by 8, that is 64 square by 8. Tell me the value.
120.
120.
120. So it is plus 120. Always keep in mind free bending moment diagram. That is a bending moment diagram which is acting on simply supported beams due to external load. They are always positive. They are always positive. Okay. This concept will also be used in your RCC continuous beam design. Okay. 120 kilonewton meter and M max for BC. What will be the formula for BC? Point load. What will be the formula for BC? BC is point load. What is the
PL by 4.
WL,
PL
right?
4.
Very good. Plus WL by 200 into 3 by, it is coming around 75 meter, right? 100 into 3 by 4, 75. So now we will plot this. Straightforward, we will plot the, let me draw this in red marker. So the free bending diagram, that is one, that is, I am erasing this part. It is 120, the topmost ordinate, while it is 75. As you know, it is point load, so the diagram will be triangular. So you can shade this part. If you want, you can shade this part. Obviously, you have to demarcate which is positive, which is negative. So this is the complete bending moment diagram. BMD for indeterminate beam. For indeterminate beam, ABC. Indeterminate beam. The same thing we use. So the same destination. If you see the same destination, we are reaching the same destination, but the routes are different. That is, first is using slope deflection. If you check, if you analyze the syllabus, your final destination is BMD. Similarly, using moment distribution, your route is BMD. If you use any other method, Canis method, for example, which is not in your syllabus, Canis method, your destination is BMD. Similarly, if you use flexibility, or stiffness method, today I will teach you stiffness method. It is also very easy. That is also your final destination is BMD. So your final destination is BMD bending moment diagram, but these are all the procedures. Now, after completing this whole problem using method 1 and method 2, please tell me, have you all understood or not? Please read the question, have a look at your solved answer, then you will tell me.
Sir,
Just have a look. If you have understood, then I can go to the next method, that is stiffness method.
স্যার
হ্যাঁ বলো।
স্যার বলছি আমরা যখন ইনডিটারমিনেট বিমের যখন বিএমডি ড্র করি তখন এই যে ফিক্সড এন্ড মোমেন্ট গুলো এগুলো অ্যাকচুয়ালি হয় হচ্ছে নেগেটিভ আর ফ্রি এন্ড মোমেন্ট গুলো হয় পজিটিভ, কিন্তু স্যার মানে কিন্তু স্যার ব্যাপারটা হচ্ছে আমরা মানে পজিটিভটাকেও অর্ডিনেটের ওপরে ড্র করি, নেগেটিভটাকেও অর্ডিনেটের ওপরেই ড্র করি, এটার কারণটা কি?
এটা অ্যাকচুয়ালি হ্যাঁ এটা বলতে যাচ্ছিলাম যে আমরা তো স্যার রেজাল্টেন্টটা বার করে দেখাতে পারি, রাইট? বাট ইট ইজ ফর আওয়ার কনভিনিয়েন্স যেটা আমরা we are plotting the end moments as well as free Bennett diagram on the same side. এটা আমাদের সুবিধার্থে আমরা প্লটটা করি। But if you plot the same beam in StatPro or ETABS, you will see the diagram, yeah, the moment diagrams will be similar to this beam. Okay.
ওকে স্যার।
Now আমাদের মেইন কাজ হচ্ছে after whenever you learn StatPro, obviously in StatPro one important thing which comes to our concern, that is in beam ABC you have to put the self weight of ABC, self weight, then the dimensions, that is the width and depth of the beam, that is extra part which is not here. Okay, but more or less the pattern of the bending moment diagram will come like this. So those after learning from the sixth semester, after learning StatPro, your task is to check the same bending moment diagram which you have used manually and which you have done after school. Just cross check that, then your design will be fruitful. Okay, এখানে কি করছি, এখানে we are not taking the self weight of beam ABC, the material concrete unit weight we are not taking, the depth of width, that is the B and D of the beam, we are not taking here. We are just taking it is a pencil, it is skeletal structure. Okay, but overall the pattern looks like same, and for our convenience we are plotting all the end moments as well as free bending moment diagram in the same. Many books, particularly I will tell you, some books are there like structure analysis by R.C. Hibbeler or structure analysis by S.S. Chakraborty. Those books are very good, but your understanding might be difficult. In those very good books, you will see that they have plotted the resultant there. Okay, please keep this in mind. So now coming to the stiffness method. Stiffness method is much easier method, because in stiffness method we use slope deflection method. Okay, to solve we do not need any critical method. Acha, now everyone please make sure the method which I told you, method 1 and method 2, in SS Bhavikatti book, I am telling you, in SS Bhavikatti book, all the numericals they have used method 2. So please try to solve those numericals using my method 2. Okay, in SS Bhavikatti book they have used all in method 2. They have used method 2, but they have used moment distribution. Sorry, they have used conjugate beam method or moment area method. Okay, just follow my method 2. You will see that it is much more easier. The answer is coming much more easier, but the answer will be same. Okay, Just at least practice 2-3 questions from SS Bhavikatti book, just 2-3 beams, and follow my method too. Okay. And mind it, this book has lot of errors, lot of calculation mistake is there in this book. Okay. Just follow the method which they have used. You calculate in your own copy. Okay. This is how we should learn from Bhavikatti book, but because it's full of calculation mistake. Now coming to stiffness method. Stiffness matrix method also, similarly, just like in flexibility matrix method, I have provided you a chart. That is a chart, the results of slope deflection, which are used for flexibility matrix method. Similarly, for stiffness matrix method, I will also send you a chart in the Google Classroom. Okay. Stiffness matrix. First of all, in the stiffness matrix, which is also known as displacement method, as I told you, displacement or equilibrium method. Stiffness method, displacement method, or equilibrium method. Okay. Now, after this, okay. So now, as I told you, under stiffness method, we have slope deflection. We can take help of slope deflection method while solving the stiffness method problems. Then under this, we have moment distribution. Under this, we have moment distribution. After today, I will take maximum one more day to end this syllabus. Okay. If you have any doubts, I am keeping the month of January for you to prepare. If you have any doubts, any sort of doubts in this subject, you can come to me. I will be in the college. In a group, you can come. Okay. Then I can teach you in the class also if you have any sort of doubts. Okay. So I'm keeping the January month free for you to practice.
Sir, can you please share the Bhabikati PDF? Actually, book is not
Bhavikati,
available in
I
the
have already I
library.
have shared the Bhavishom. I have already shared the Bhavikati PDF in the Google Classroom. দেখবে ম্যাট্রিক্স মেথডের পুরো নোটস আছে, এবার
Okay,
দেখে
sir.
নিও, করে
Okay,
দিয়েছি।
sir.
For practice, please follow the Bhavikati book. It's a very good book. I am not telling another book. There is also a very good book that is S.S. Ramanutham, a big fat book. It has a lot of questions, but I will tell you not to do for time. Okay. And also we have minimum potential energy method. Small amount of method is there under stiffness or displacement method, slope deflection, moment distribution, and minimum potential energy method. Minimum potential energy theory. So these three methods, they follow the stiffness or displacement method. Okay. Now coming to the various, coming to the various properties. Coming to various properties of stiffness method. Stiffness method is almost also the matrix is very much similar to flexibility. Okay. And now two important points. Please write down properties. Important properties of stiffness method. Is the whiteboard visible, right? The writing.
Yes, sir.
Important properties of stiffness method. As I know, stiffness method is represented by either S, or in some books, in majority of the books, it is written by small k. K stands for stiffness. Okay. The important properties of stiffness matrix. First is very much similar. The main diagonal elements, write down. Similar to flexibility method, the main diagonal elements are non-zero and non-negative. Please write down the main diagonal element. Acha, again I'm telling you the next class I may take on Thursday. Okay, Thursday morning, so that I can take a combined class. I'm telling you, all of you, much before Thursday I will take on it. So main diagonal elements, similar to flexibility matrix, the main diagonal elements are non-zero and non-negative. Very important. Are non-zero and non-negative. The main diagonal elements are non-zero and non-negative. Very important. That is, here we represent like this. For example, K11, K21. Here also we have the stiffness coefficients. Stiffness, just like in flexibility coefficient, F11 represents displacement at 1 due to unit force at 1. K11 represents, please someone tell Shobik Kundu, rule number 82, not to join. Okay. Okay. Shobik, I have joined too, but I will not take your attendance. So K11, coming to the stiffness coefficient. This is a stiffness coefficient. For example, I am taking 2 by 2 matrix. So K11, K21, K12, K22, let us consider 2 by 2. Okay. So this stiffness matrix, for example, K11. K11 means the force required at 1 due to unit displacement at 1. Force required at 1 due to unit displacement. So Kij, let me represent Kij is nothing but the stiffness coefficient. Write down. Kij represents stiffness coefficient. Kij represents stiffness coefficient represents force required at coordinate 1, force required at coordinate I due to unit displacement at j. Due to unit displacement, force required at coordinate I due to force required at coordinate I due to unit displacement at coordinate j. Stiffness coefficient represents the force required at coordinate I due to unit displacement at coordinate j. Okay. So first important property, main diagonal elements are non-zero and non-negative. Second is the size or order of matrix. Size or order of matrix depends on degree of kinematic indeterminacy. Here, dk is more important. ds is not important. The size or order of matrix depends on the degrees of freedom, or you can write dk. So here we will find out the dk, not ds. That means how many joint rotations, how many joint movement. Dk means what? Dk also we have some special formula, but dk is basically the joint rotation or joint movement. How any joint, fixed joint, pin joint or roller joint, they can rotate or they can laterally move. That is the freedom. The freedom to movement is basically the value of dk. dk is degree of kinematic indeterminacy. No? Degree of kinematic indeterminacy. Degree of kinematic indeterminacy. Right? So dk is very much important. dk is very much important. Here dk always you should keep in mind axial deformations. For example, I have a support like this. So the axial deformations are taken are neglected. So delta x are axial deformation or axial displacements. The axial deformations, they are neglected, are ignored or neglected. Even though axial deformation means actually it can move right or left, right or left, right or left, right? So these axial deformations, they falls under the decay, but to find out the stiffness matrix, we ignore this axial deformation. We ignore this axial deformation. So we ignore this axial deformation. So the two important points, first is decay is more important. We have to find out decay. Second is all the main diagonal elements. Main diagonal element, they are non-zero as well as non-negative, which is similar to flexibility matrix. Third is axial deformations. In frames also, in frames subject to lateral loading, in frames, in frames under vertical load, frames under horizontal load, continuous beams under vertical load. In all the cases, the axial deformations, that is axial movement, they are neglected or ignored. Okay. Now I'm giving you 5 minutes break. After that, we will start with the numerical on stiffness method. So mind it, here we will use slope deflection method. Okay. Slope deflection method, I will go step by step. I will take a similar problem. I will take a similar numerical, just like we have done in flexibility matrix, and we will solve. We will see it is much more easier compared to flexibility matrix. Okay. So I'm giving you 5 minutes. Okay, all of you ready? All of you ready, my dear students? आ गया सब?
Yes, sir.
Okay, thank you. Now coming, so we will do the similar. You will see the main thing is that the comparison. If you do the comparison between the two methods, you will see that time required is less in case of stiffness method slightly, and it is slightly easier. But I should not say it is easier because it is subject to me. So to some one person, it is difficult also. But I have checked if you use the Bhavikatti method and if you use this method, it is much more easier. But if you use the method 2 of flexibility, which I taught you today, that if you use that, it will be simpler to stiffness. Okay. I will take the same numerical and we will see that the same bending moment diagram is coming in this case also. Okay. So let us come to the numerical of stiffness method. Numerical on stiffness matrix method. Numerical on stiffness matrix method. Okay. So see here we will do the same question. Analyze the continuous beam. Analyze. If the question comes that only analyze the continuous beams using this and this method, at the end you have to draw the bending moment diagram. Okay. With pencil, obviously. Analyze the continuous beam using stiffness method. Okay. We have to plot the bending moment diagram. Automatically, it is evident. Automatically, it is known that you have to draw the bending moment diagram. If you are, if you, and even if you, even in the same case for slope deflection or moment distribution methods, if you do not get time for SFD, please draw the bending BM. Okay. The same numerical, we are taking the same numerical problem. Beam ABC with prop beam, prop cantilever. AB under the same, just copy the same number. AB is under UDL of 60 kilonewton per meter. It is a 4 meter. Now coming to BC. BC under point load 100 kilonewton. Okay. So the same numerical we will take to solve using stiffness method, and we will draw the bending moment diagram. We will see the same BMT is coming. Okay. Just the procedure is different. So first draw the diagram. Obviously here EI is constant. EI always, please, another important thing, make sure in all these methods, slope deflection, moment distribution, flexibility matrix, stiffness matrix. In all these four methods which you have learned in this semester, please make sure the EI, the flexural rigidity, is it same or is it different? Please be cautious in this part. Okay. So first, what will be step one? So are you all ready? Have you copied this numerical? Please copy this. After you have copied, please tell me, then I can proceed. So I'm proceeding. Can I proceed? अरे सब सो गए क्या? Have you all slept?
Yes, sir.
No, sir.
Please till 12 p.m. I will take the class, no problem. Okay, just half an hour more. Okay, solution first is step 1. Find out the decay. Determine the degrees of freedom or determine the degree of kinematic indeterminacy in the whole structure. Determine decay. Okay, so decay you can use the formula also, but here decay, what we know, decay means degrees of freedom, or you can say number of joint notation, free independent joint notation. That means it can move degree of freedom, or you can use the formula, or if you're not using formula, you can see the diagram also and you can yourself find out decay. Decay is very simple. Or independent joint rotation, that means the supports which are able to rotate. Independent joint rotation. Okay, degrees of freedom or independent joint rotation. Okay, decay. So now here if you see, A is fixed end, B is roller, C is roller. So we all know that fixed end, it is fixed completely. Complete fixity is there. So B and C, it can only undergo rotation. So B I am taking as coordinate 1, C I am taking as coordinate 2. So therefore theta B, sorry, yes. So now the degrees of freedom, there are 2, decay is 2. Where? Joint rotation at B and C. Joint rotation at B and at C. Why? Because it is roller supported. Roller support. So we all know roller support, the beam can rotate. Okay. So here decay is 2. Okay, decay is 2. So in the step 1, determine decay and coordinates. So I am assigning the coordinates. Step 2, you can write down. Assign the coordinates. Assign the redundant supports as coordinate. Redundant support as coordinates. Okay. So I'm putting joint B as 1, joint C as 1. Okay. So basically, so what is the unknown here? So therefore, theta B. So theta, sorry, yes. So theta B unknown. Theta B means coordinate 1. Theta B means coordinate 1. Similarly, theta C coordinate 2. Why I am taking this coordinate? Because C is roller support, B is roller support. Even if it is roller or hinge support, here this beam can move like this. Okay. So here unknown 1, unknown 2. So step 1 is find out the decay or degree of freedom. Step 2 is assign the redundant support as coordinate. Step 3 is very much simple, which you have got tired to doing all these things. Make the supports as fixed end and find out the fixed end moment. Write down. Provide. Step 3 is provide fixity to the beams. Provide fixity to the beams. That means I will convert this beam into fixed beam. Fixed end beams. Okay. I will provide fixity to the beams. That means I will fix this beam and I will find out the fixed end moment. Fixed end beams and find out fixed end. Find out fixed end. Okay. So first thing, I will convert this beam into obviously indeterminate structure. So it provides fixity. So I will, whatever support is there, roller support, fixed support, I will fix this beam. Okay. It is 60 kN per meter. So I have to draw the whole beam. This one, body figure 1. So we have to show, I will fix the both the beams, beam AB and beam BC. If we will have 3 beams, then it will be 3 beams. Okay. So here we have 2 beams, AB and BC. So I'm making it fixed, AB and BC. AB and BC. Okay. So find out the fixed end moments. So let us find out fixed end moments. So FEM AB, or you can write down whatever whatever representation you represent. So fixed and AB, but what will be the, so now I have converted this AB into two fixed end. I have converted into fixed end. Now find out FEM AB, FEM BA, FEM BC, FEM CB. So FEM AB, how much it will be? Minus W square by 12 UDL. So FEM AB minus W square by 12. Now what it is coming? Fixed end moment. Find out the fixed end moments. AB, BA, BC, CB, and tell me the answers.
80 kilometers, sir.
FEM AB is minus 80. You know the left hand side is negative, right hand side is positive. 80 minus 80 kilometer. Similarly, BA plus 80. So AB minus 80, BA 80. Similarly for BC, WL by 8. Minus the BC minus WL by 8. It is coming minus 37.5 km. And FEM CB, it is 37.5 km. So it is very simple. I am finding out the decay first, then assigning the coordinates, then I am fixing the beams AB and BC, and after fixing the beams, I am finding out the fixed end moment, which we have all done in slope deflection as well as moment distribution method. We have done AB, BA, BC, CB. Okay. So now after finding this, yes, after finding this,
আমরা যখন স্লোপ
yes,
ডিফ্লেকশন করেছিলাম স্যার, তখন আমরা মানে অ্যান্টি ক্লকওয়াইজটা নেগেটিভ ধরেছিলাম আর ক্লকওয়াইজটা পজিটিভ ধরেছিলাম স্যার।
হ্যাঁ এটাই করি আমি, সেটাই অ্যান্টি ক্লকওয়াইজ সেটাই। I don't go with the sign, ঠিক আছে, এই সাইনটা দেখো না, আমি জাস্ট রিপ্রেজেন্টেড দিস। ওকে, লেফট সাইড নেগেটিভ, রাইট সাইড পজিটিভ, এভাবে আমরা করি like this. Okay, like this. So now after we are coming, so A is coordinate 1, sorry. Okay, so now coming to this one, that is, so B is coordinate 1 and C is coordinate 2. Okay, so after getting all these fixed end moments, we will find out the resultant moments, the resultant fixed end moments at coordinate 1 and 2. Write down. So after this, in step 3 only, find out the total forces developed at coordinate 1 and 2. Total forces developed at coordinate 1 and 2. So at 1, So I am representing it as PL. PL meaning the total forces. This representation we will use in the last step. The last, that is the equilibrium equation. When we'll use, I will show you that PL. Okay. So PL is a matrix which represents the external forces. External. Okay. So now this PL, here we have two coordinates, PL1 and PL2. B as coordinate 1, C as coordinate 2. So for PL1, so we will just take the fixed end moment. So at point B, we have two fixed ends, that is fixed end moment BA and fixed end moment BC. We will just take the cumulative BA plus fixed end moment BC. While at point C, we will take only CB. Only CB. So coordinate 1, support 1, so BA plus BC, fixed end moment of BA plus fixed end moment BC. And for PL2, CB. Okay. So the fixed moment of BA was 80. 80 minus 37.5. And for PL2 plus 37.5, we are getting the value 42.5 and 37 point. So these are the moments, and as you know, moment is also treated as external forces. So these external force is coming due to the fixed end moment. I am keeping the beams fixed, and due to fixity, fixed end moments are coming, and due to these fixed end moments, we have having, or the supports are experiencing extra additional moments. Supports are facing extra additional moments. So please, step 1, step 2, step. Okay. Achha. So till this, I am ending today's class. On the next day, in the step 4, we will find out how to develop the stiffness matrix and to solve the stiffness problem.
স্যার
Bol.
স্যার আজকে ফার্স্ট যে মেথডটা করালেন, যেটা ফ্লেক্সিবিলিটি মেথড ছিল, সেখানে এই সেম প্রবলেমই করেছিলেন, বাট সেখানে আমরা কোঅর্ডিনেটটা কনসিডার করেছিলাম, একটা হচ্ছে ফিক্সড এন্ডে কনসিডার করেছিলাম, একটা মিড স্প্যানে করেছিলাম, আর এখানে করছি মিড স্প্যানে আর শেষটাতে। তো স্যার এইটা কেন হলো, এটা একবার।
এটা কেন আমি যে বললাম, এই যে দেখো ফিক্সড, আমাদের এখানে কোনটা দেখতে হবে, আমাদের এখানে দেখতে হবে হচ্ছে ডিগ্রি অফ ফ্রিডম, অর্থাৎ কোন কোন জয়েন্ট মুভমেন্ট করতে পারছে। That means the joints where the beams can move. Fixed end, it is completely fixed, so there is no movement. In hinge and roller support, if you see, there are in roller support there is one unknown, that is a reaction, and in hinge there are two unknowns, reaction as well as movement. So in the roller and hinge support, if you see that degrees of freedom, the beam can move, the beam can rotate rather. So that is why at A it is fixed end, so I am not taking this. So I am taking this point B, I am taking this point C. So I am taking the coordinate 1 at B, coordinate 2 at C, because these are roller support, and at this the beam can move. I told you the joint, the independent joint rotation or degrees of freedom. Have you understood? কেন নিলাম coordinate গুলো?
ইয়েস স্যার, ইয়েস স্যার। আর স্যার ফার্স্ট যে প্রবলেমটা করলেন, যেটা ফ্লেক্সিবিলিটি মেথড দিয়ে, সেক্ষেত্রে মিড স্প্যানেরটা কোঅর্ডিনেটটা আর ওই ফিক্সডটা কেন নিয়েছিলেন তাহলে? মানে ফিক্সড এর রেসপেক্টে তখন তো মিটার তো রোটেট করছিল না।
হ্যাঁ রাইট, কেন ফিক্স প্যানে আমার কি ছিল, ওখানে আমার ফিক্স প্যানে তো আননোন মোমেন্ট ছিল। There the necessary was the unknown moment. At fixed end there is unknown moment. Fixed end moment থাকে because we have three unknowns: reaction, vertical reaction, horizontal reaction and moment. So at fixed end there is unknown moment. At B, intermediate support, unknown moment is always there. And at C, the free end, C the key হয়.
Moment zero.
Since it is roller support, or we can see at C it is simple support ends at the end. So here we know the bending moment always comes 0. Always remember at the end, in the left end or right end, যদি hinged end or roller end থাকে, bending moment is always 0. Just consider I am drawing this beam. For example, this portion, for just example I am drawing like this, A, B, C, D. So in A, B, C, D, if you are going to use slope deflection or any, if you are finding out the coordinate system, if you put the coordinates, A and B are simply supported at the ends. So bending moment at A and D is 0. So here it is 0, D is 0 because at the ends, the only unknown is left at B and C. বোঝা গেছে কেন করেছি আগেরটা?
ইয়েস স্যার, ওটা তো ক্লিয়ার আছে, ওটা তো ক্লিয়ার হচ্ছে। তার মানে স্যার বেসিক্যালি ফ্লেক্সিবিলিটি মেথডে আমাদের মানে মেন কনসার্নটা হচ্ছে যেখানে যেখানে মোমেন্টটা আসবে সেটাকে আমরা দেখবো, মানে সেই কোঅর্ডিনেট গুলোকে আমরা নেব।
যদি তুমি মেথড 2 ইউজ করো, মানে মেথড 2 ইউজ করাটাই ম্যাক্সিমাম লোকে করে বিএমডি আঁকার জন্য। মেথড 2 যদি করো তাহলে যেখানে যেখানে মোমেন্টটা আননোন, মানে যেখানে মোমেন্টটা নন জিরো হবে, সেখানে আমাকে কোঅর্ডিনেট পুট করতে হবে। এই 3টে হতে পারে, 4টে হতে পারে, 2টো হতে পারে, যা ইচ্ছে। ঠিক আছে? আর এখানে হচ্ছে বিম যেই সাপোর্টে বিমটা মুভমেন্ট করতে পারছে,
সেখানে সেখানে
যেমন
কোঅর্ডিনেটটা
ধরো
পুট
আরেকটা
করতে হবে।
যেমন আছে ইন্টারনাল হিঞ্জ না, ধরো আহ, আহ, ধরো একটা একটা এমন সাপোর্ট, ধরো রোলার সাপোর্ট বা লিঙ্ক, অনেক সময় আমাদের লিঙ্ক দেওয়া থাকে, লিঙ্ক সেখানেও আমাদের বিম কিন্তু মুভমেন্ট করতে পারে, দ্যাট ইজ অলসো আ কোঅর্ডিনেট। ঠিক আছে?
ওকে স্যার।
ফিক্সড এন্ডে কি হয়, ফিক্সড এন্ডে বিম একদম মুভমেন্ট করতে পারে না, কমপ্লিটলি ফিক্স। এনে আমি ফিক্সড এন্ডটাকে বাদ দিই। ঠিক আছে? Okay. So now coming to the attendance. Okay, just wait. Let me take the attendance. First, I'm starting with section A.